everyone, and welcome to the lecture on image filtering. Filtering means replacing a pixel value in a given image with another pixel value in its neighbor. Okay, so you take your neighboring pixel value and replace it for another pixel value. That's what filtering means. And filtering is used to enhance certain features of your image, or it's also used for reducing noise in your image. Let's start by importing the libraries and modules that we need. I copied this from one of our previous lectures. And let's set the default color map to gray by using Matplotlib's RC_param method. Let's do that. So plt.rc_params. Then we'll pass the image.color map and set it to gray. What we'll do next is create an array of zeros using NumPy's zeros method, and then index some of the values and set it to be equal to a different value, and then we'll use the subplot method to see our image. Let's do that. So np.zeros, and let's pass 200, and I'll save this in a variable called normal. And what I'll do next is I'll take my arrays and then index it from 100 onwards and set the values to be equal to 15. Okay, then let's plot our array. Okay, so we'll say figure and axis is equal to plt.subplots. Then we'll take our axis, then call the plot method and pass our normal object that we saved. If we run this, we get a plot that looks like this. So from 0 to 100, the values are 0, and then from 100 onwards, you see here the values are 15. So you see 15 from here, from 100 onwards. Here the values from 0 to 100 lie on the x-axis. So what I will do is there's a method known as margins, and let's call the margins method axis.margin, and let's pass a value of 0.2 to better visualize our graph. This is much better, right? What I'll do next is introduce some noise to our figure, to our graph. For that, I'll be using NumPy's randn method, and then finally save it in a variable called noise. So noise is equal to, we'll take our normal object, which we define here, and then add some noise. So np.random. Don't worry about how I'm using this, how this method works. I'll just be adding some noise. Okay, so np.random.randn, and then I'll take our normal object and then call the shape method on it, and we'll multiply it by 2. That will introduce some noise to our object. Once we have that, let's plot it by using the same mechanism as in here. So we have our figure and axis, then we'll set it to be equal to plt.subplots. Then we'll call the plot method on our axis and then pass our noise object. Let's run this. Okay, it looks like that. And let me also pass the margins method to make it consistent. So axis.margins, and I'll use the same margin as I used above, 0.2. Now here you see that noise is introduced, right? You see a noise here and noise here. So if you compare these two figures, one is derived from the other by adding some noise. And what we'll do next is try to get our original or our normal figure from this noisy figure. And one method to do that is to take 2 pixel values and then calculating the average or mean between 2 neighboring pixel values. Okay, that's what we'll do. We'll take 2 pixel values and then take the average and plot that figure, plot the average. So that will give us an image that will look close to our original or normal image. Let's do that. So we have our noise object, and we can take any pixel value. Let's say -5. Let's say up to -5. We'll index it, okay? And then, so this will be 1 pixel value, and then let's take a neighboring pixel value. So let's say noise, and then we'll say from 5 onwards, okay? And to take the average between 2 pixels, all we have to do is divide it by 2. So this divided by 2, and we'll save this in a variable called average. Now we can plot by using the same mechanism as above, and we'll pass average. So we have our figure in axis, plt.subplots. Then we'll call the plot method and then pass our average object. And same as above, we'll use a margin of 0.2. Margins 0.2. Let's run this. So we have an error here. So this is margins. Let's run it again. So this image looks more similar to our original normal image. Okay, so that's the method that we use to draw an image that looks similar to the original image. We take 2 neighboring pixels and then take their average or mean and then plot the average. So this is just an introduction to image filtering. Again, filtering means replacing 1 pixel value with its neighboring pixel value. And in the next lecture, we'll continue our discussion on image filtering. Thank you, everyone. Hello, everyone, and welcome to the lecture on Color Channel.